Developing the habit of good reporting for analysis or acquisition has several aims. The first and most important reason is reproducibility. This can be for yourself, so you can pick up a project after an extended break, or so that someone in your group can replicate or continue your work. At BOMP, we can always help you recreate an old workflow, but this is time consuming and there's always more than one way to achieve a desired output with image analysis, which can also lead to some slightly different outcomes or results. The next reason is knowledge retention, which is often overlooked when it comes to microscopy. But when someone graduates or leaves their role, they often take the knowledge of how those experiments were done with them. And better reporting reduces the burden on the people taking over and means you can avoid starting from scratch with each researcher. The final point is that you will eventually need to document these steps for a paper or a thesis, so it's just better to start now. And this also makes it a lot easier for external users to replicate the analysis using your published work. For reporting, your most important tool will always be your lab book. So it's always important to take note of the main steps and settings used at each stage. Don't just rely on image metadata to record your experiment for you. However, some programs such as Amaris have areas for you to add comments and more detailed descriptions, and I'd recommend doing this at least once for a good representative example. Other programs like Zen allow you to edit the names of the tracks and channels to be specific to your experiment, and this allows you to edit the metadata a little bit at the acquisition stage. Image analysis can be difficult to describe at the best of times, especially if you are new to this area. So another thing to consider when recording and documenting your analysis is to save a digital record. This can be in the form of templates that contain specific settings, or saving a representative example with the completed analysis. The main advantage of doing this is reproducibility, as an image file will always contain more information than you can write down, and this makes it easier to troubleshoot any issues with the workflow in future. For example, here you can see this Amaris file has a detailed description for each object, and the parameters for each object can also be exported as a separate file. You might not do this every time you analyze an image, but it's a good practice to do this at least once and create a representative example and templates of the whole workflow. Another good tool for keeping a digital record is in Fiji you have the recorder function, and that lets you record all the processing steps that you've done and save them as a text file.
So far, we have covered the four main steps in bioimage analysis: acquisition, pre-processing, segmentation, and measurement. Hopefully this has given you an idea of the types of analysis that is available. And if we were to put every step in an image analysis workflow together, it would look something like this. So Cell Profiler is a modular-based program, and we'll create a workflow like this using preset templates that can be tailored to your data. Additionally, if we wanted to automate our analysis, we can use scripting tools. For example, in ImageJ, we can write macros that record processes and then replay them using the ImageJ macro language. And we have a workshop in macro writing coming up in June. There are a wide range of other software packages that you can use to automate your analysis. This can be a little bit challenging and involve some programming, so you can collaborate with BOMP to investigate how these tools can be used for your image analysis. Sometimes it is challenging to create a workflow from scratch, and it may be more effective for your research if you work with BOMP on a collaborative basis.